Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to set up the framework for building 3D parametric surface based on a set of parametric equations. In this video, I will explain how to use the parametric surface data function to create a typical parametric surface, that is the Klein Bottle. In topology, the Klein Bottle is an example of a non-orientable surface. It can be constructed by joining two sides of a paper sheet to form a cylinder. Then loop two ends of a cylinder back through itself here in such a way that the inside, the green, and the outside, the white of the cylinder are glued together here to form the Klein Bottle, like this. Here is the animation for constructing the Klein Bottle. Even though the construction of a Klein Bottle looks very simple, however, its parametric equations are very complicated. As shown here, you can see x, y, and z as a function of uv. uv are parameters. You can see the expression for this set of parametric equations are very complicated. You can see here u is in the range 0 and pi, v in the range 0 and 2 pi here. Again, here we will use the git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download the source code used in the last video. Now open a command prompt window and run the following command: git clone, and paste this link. This will generate a WebGPU 27 folder on your local machine. This folder contains the source code used in the last video. Now we want to change the name of WebGPU 27 folder to GPU 28. Rename 28 and cd into it. At this point, we are going to start Visual Studio Code with the command code period. This is the Visual Studio Code interface. Okay, we can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window and run the command npm install to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the node modules folder. First, we need to add the Klein Bottle function to the mathfunc.ts file from src folder. Open the mathfunc.ts file. Here we need to add the Klein Bottle function. This is the code for the Klein Bottle function. You can see this function takes u, v, and center as its input arguments. Here the center parameter lets you set the location for the Klein Bottle. Inside this function here, we define x, y, and z as a function of u, v, using these parametric equations. This function returns the vector point on the Klein Bottle surface. You can see here x, y, and z. Now we can save this file and we can close it. Next, we need to make some changes to the index .html file from dist folder. Open this file. First, we need to change the 26 to 28 because this is 28 videos. Here we also need to change the H1 title from peak surface to Klein Bottle. The input parameter used here will be the same as those used in the previous video for creating the simple surface. Now we can save this file. Next, we need to make some small changes to the main.ts file. From SSC folder, open main.ts file. Most code will be similar to that used in the creating a simple surface, except here that we need to introduce the parametric surface data instead of simple surface data. So we need parametric from surface data.ts file. Next, we need to change the peak function from mass.func.ts file to Klein Bottle. Inside this create surface function, here we need to change the simple surface data to parametric surface data. And inside, we also need to change the mass function from peaks to Klein Bottle. And here, we also need to change the U range to 0 to pi, and V range to 0 to 2 pi. And set the UV divisions to 70 and 30. Next, we need to add the X range from -2 to 2, Z range from -2 to 3. Here we will keep the scale Y, and color map name as input arguments. Or the other part of the code is the same as that used in creating simple surfaces. With this framework set up and following the procedure described here, you can easily create your own 3D parametric surfaces in your WebGPU applications by simply define your own parametric equations. Now we finish the modification to the main.ts file. We can now save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bundle our TypeScript code in the production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link from the status bar area to open Chrome Canary to view our Klein Bottle. Click this link. Here is our Klein Bottle with the default lighting and the color map displayed on this page. Here the scale set the default size of the surface. So if we change to 1, you will get a smaller Klein Bottle. So we will set it back to 2. The scale Y setting the aspect ratio of the Klein Bottle. If we change it to 0.5, you can see you can get a short and fat Klein Bottle. Okay, let's change back. Next, we can change the color map here from this drop-down menu. For example, this is an item. This is the bond. This is Q. This is Cooper. Grades. Hot. HSV. spring, summer, and winter. This is default jet. You can also click the camera control button. You can use your mouse to control the movement of the Klein Bottle. You can see inside. You can click animation again. The Klein Bottle will rotate continuously. Now we have completed this example. In next video, I will show you how to create a very cool surface with both the lighting and color map effects. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.